Then it gets kind of easy again after 28, so just picked up from there, 29. Okay, so the trick is, what makes these problems harder is that both sides have the variable in the exponent. And step number one is, if these two things are equal, then the log of these two things should be equal. Okay, that's step one. So all I did was put both of those into a log. And I'm using the common, it doesn't really matter what log you use, but I'm using the common log, base 10, right? It'll make it easier for our calculators later on. The reason that you would want to do that is because now we can manipulate the exponents. This goes back to Monday's worksheet. What can I do with this exponent right here? Or this exponent? Remember what we did on Monday with the exponent? It can go down in front, remember? Once it's in log form. So, you guys not remember? Do I need to review that a little bit?
No.
Actually, let's do, because I wanted, all three of these things we kind of need today, so let's talk about it a little bit. So, log of 3 plus log of 4, do you guys know what that equals? What do we do with these numbers? Multiply. This is the worksheet we did on Monday. If you're adding the same logs together, you can multiply their numbers. So it's equal to log of 12. So what would log of 3 minus log of 4, what would that equal? Division, so it'd be log of 3/4. And then the other thing we did was like log of 3 to the 4th, and you can move the exponent down as a multiplier. Whoops. So it's like 4 times log of 3. All right, got those in your brain? Because like one of these shows up on all of them, at least one. Okay, anyway, so we can move the exponent down in front as a multiplier. So this is a plus 2 times log of 7. Log of 7, I know it looks weird, but really that's just some weird decimal. It means like 10 to the what equals 7. So this is just one, think of this as one number, some weird decimal number. Okay, and then the 2a can come down in front of this log.
Is the test going hard? How many questions are on the test?
52.
What
I'm planning right now the schedule, and we're on schedule is starting the review on Friday. Yeah, hopefully Tuesday. Well, we'll see.
It's not like common sense.
Yeah, it's not a guaranteed 2-day. It might actually take a little more. Okay, so the next step I'm going to do is distribute the log of 7. So it's a times log of 7 plus 2 times log of 7. All right, now, what are we trying to get to exactly? Where are we going with all this? What are we trying to do? What are we trying to find? A, that's our variable. That's the only variable, right? All this log 7, 2 log 7, this is just some number, but there's no variables in it, it's just some number value. So how do I solve for A? Well, you want to get A on one side and then get it by itself, just like always. So I need to get A on one side, so I'm gonna bring this A term over by subtracting. Do these two, I should have asked this first, do these two mix? Do they go together well? No, they don't. If they were both like a log of 9, we could have done something with that, but not really. What we can do, we've used this trick a couple times, not often, but what we can do is now take an A out of both of those. Like factored out. We're actually pretty close to done here. I think this part of it is just looks intimidating because look at all that weird stuff right there. But really, is there any variables inside here? No. This is just one numerical value, some weird decimal. But how do I solve for A if all this is multiplied to A? Divide by all this. So I'm just going to divide both sides by that thing. Probably don't want to plug it in your calculator at this point because then you have to round it off. And if you use a rounded off value, you'll get a less accurate answer. But anyway, that goes away, whatever that value is. And this is just a number, some weird decimal. So A equals blah, 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 blah. How could we plug that in the calculator? Well, you could use, oh, who had the not good calculator? Did you get a good one?
No, I'm choosing those.
Oh, okay. Oh, yeah. Well, you could do it with the other calculator. It'd be challenging to make sure you plugged it in all right. You could use the fraction button like a lot of you normally do, or you could do the division button and then just put the denominator in parentheses to make sure that's done before you divide, or you could use the fraction button like normal. It's probably what most of you do. Either way, let's plug that in and see if we get it. I think it was between 1 and 2 if I remember right. Somewhere between 1 and 2.
$5,894.
5984.
5894.
5894. Yeah. Do you guys remember yesterday they told us to go to the fourth decimal place, the 10,000th place? So, yeah, I'm pretty sure that was right. That sounds right. All right. So you see why I made 26 and 28 a bonus. It's pretty much the same problem though. So if you can repeat the steps, you should be good. Then it gets kind of easy again at 29. All right, 29. Speaking of double, yes, relatively easy. 125 equals 3. Well, I said easy, but I don't know. Maybe you guys forgot what we were doing yesterday. Any ideas what we should do here? Right, change it to exponential form. B to the third. Remember the ACB thing? Do this one, this one, this one. So it's B to the third equals 125. So how would I solve this for B? How do I get rid of this cubed on the B? Cubed root. Some of you might know this one by heart. Does anybody know what cubed equals 125? Yeah. But if not, just plug in cube root. And yeah, you get a 5. I should probably make a small note here. Is this possible? The answer is no, because like 5 to the what power equals negative 25. That's what this means. 5 to the what power equals negative 25. That's not possible. Like 5 to the second is positive 25. 5 to the negative 2 is like 1 over 25. Nothing makes the base switch from positive to negative. So this, if you plug this in your calculator, just say error. This is going to kind of apply to the last problem, I guess, but or second to last problem or whatever. Anyway, they're not going to let you do that with the negative right there. Just doesn't work. So the last problem was like, I don't know, I don't remember what it was, but it's something like x squared is 25. So normally when we square root both sides, it was like plus or minus 5. But in this case, the negative doesn't work on the log. So, or something like that, I don't remember. 31. All right. Log base 3, x minus 6 equals 4. Alright, so how would that one set up? This one's more like yesterday's. Right. This just means 3 to the 4th equals x minus 6. So 3 to the 4th is just a number, but how would I solve this for x? 3 to the 4th is 3 times 3 is 9, 3 times 3 is 9, 9 times 9 is 81. 81 plus 6. Alright, speaking of that worksheet on Monday, log base 4 of x minus log base 4 of 9 equals -3. Alright, how can we simplify this? So we can't just set up like this to this power to that. It's too messy over here. We gotta clean this up. How can I simplify this left side? Right. So if you subtract the same log type, what do we do with these things? Divide. So this turns into log base 4 of x over 9. Should have made you guys review that yesterday, shouldn't I have? Forgot those things. The worksheet. Alright. So now it's kind of a basic log. So now we can turn it back into exponential form. So wait a second, Shelby. What would this be in exponential form? 4 negative third. Okay, 4 to the negative third is just some number. 4 to the third is 64, so this would be 1 over 64. But how am I going to solve this for x? Times by 9. Times 9. So 1 over 64 times 9 over 1 is 9 over 64. Now on the directions they did say the 4th decimal place, but they did go ahead and leave this one as a fraction. They didn't follow their own directions, but I'm going to do the same thing. We'll just leave that as a fraction. Alright, I knew you guys would really want to do a word problem, so let's try 37 and 38. Do you recall the exponential growth formula we learned. When did we learn that? I guess it was last week, because what did we do? We didn't do it yesterday, because we were doing this. So it must have been last week. You guys remember how the exponential growth stuff works? You like have a starting amount, and you like 1 plus r, that's the rate of growth, the t power, that one. The compound interest, which is not really today, but remember what changed on the compound interest? R over K, so KT. Okay, so we're not doing compound interest right now, so we're just sticking with basic exponential growth, so we're using that one. 37 says, $26,000 sports car loses 15% of its value each year. When will the car be worth $10,000? Okay, so this book must be old, because you can buy a new sports car for $26,000. No, you cannot. Okay, anyway, where am I going to put that $26,000? Right, starting amount. Hey. $26,000 is what we're starting with. It says it's supposed to lose 15% of its value every year. Right. Yes. 15% as a decimal is 0.15. And since we're losing 15%, it's 1 minus 0.15. Which you could leave like that, but what does that simplify to? It's kind of like, what's a dollar minus 15 cents? 85. So this will be like, every year it's going to only be 85% of what it was the previous year. And how many years? Oh, we don't know how many years. That's the kind of question. So that will be a t. But we want this value to go down to $10,000. We want to figure out how many years before the price is going to drop to $10,000. So this is this is what they invented log to solve. This is what log was made for, when the variable is in the exponent. All right. Now, can we clean this up a little bit? Any ideas? How can we clean this up a little bit? Yeah. Let's get rid of that guy. So it's just like a number to a power equals something. That'll make it simple, right? So how do I get rid of 26,000? Divide it, because it is multiplied. So that goes away. Okay. That's going to reduce 10 over 26, 5 over 13. Let's leave it like that. All right, now that we have it in exponential form, we need to change it to what? Log form. So in log form, it's log base, what is the base? 0.85, remember ACB, right? A, C, B. And this is just a numerical value that we got to figure out. It tells us T stands for how many years before the car is only going to be worth, $10,000. Let's see, where did the book round us to? They rounded it to the 10th place. Oh, it says in the directions, round it to the 10th place. All right, anybody get it?